Hey guys, this is our first section of Unit 3. We're going to be talking a little bit about graphing relationships. Okay, so when you're talking about graphing relationships, we will always use, this is your first key term, you will always use graphs to show a relationship between two sets of data. Okay, we use graphs to show a relationship between two sets of data. Okay, and in this unit, you'll be looking at graphs a lot and analyzing the what's going on in those graphs. Okay, so for example, below here you have a little scenario. Okay, and in this section, you're going to be given scenarios, and you're going to have to decide which graph goes with that scenario. Okay, so it says the air temperature was constant for several hours at the beginning of the day and rose steadily for several hours. It stayed the same temperature most of the day before dropping sharply at sundown. And we want to figure out which one of these goes best. And there's 3 steps that you need to know to decide which graph fits best. Okay. The first step to decide which graph would be the best is to read the graph from left to right. Okay, read the graph from left to right like a book. First step is to read the graph from left to right to show time passing. Okay, take a second to write that down. Okay, your second step is going to be to list keywords and decide which graph is best. Okay, so list keywords and describe which graph is best. Okay, and then finally, step 3 is going to be to pick the correct graph. Okay, so here's your 3 steps in deciding which graph is going to be best for you. Okay, now when you go ahead and look at your scenario that's listed up top, okay, there's several different keywords. Okay, the first keyword that you're going to want to look for is constant. Okay, and whenever you see a keyword that is constant, you always know that when you draw the line in the graph that it's going to be horizontal. Okay, the second one in your sentence that we read up top was rose steadily. And when you rise steadily, you're just going to have a slightly upward slanting line. Okay, your third one stayed the same. Okay, stayed the same. I know my handwriting's terrible. And when you stay the same, of course, you have a horizontal line in math words. Okay, and then finally, it dropped sharply. Okay, and that would be a downward slanting line. So here are the 4 keywords and math words that go with this scenario that we read. Okay, now if you put those in order, our constant line, our rose steadily line, our horizontal line, and our sharply decreasing line, well, the only graph that is that option is this graph right here, graph B. So the correct graph would be B on this guy. Okay, so this section is basically just using these 3 steps and deciding which graph goes with each of the scenarios. All right, so we're going to read the scenario, pick out keywords, and decide which graph goes with it. It says, each day, several leaves fall from a tree. Okay, so that's a keyword for us. Several leaves fall from a tree, so we know leaves are going down. So since graph A, the leaves are going up at the beginning of the graph, well, we know that this graph is not correct. Okay, then it says, one day, a gust of wind blows off many leaves. Okay, so it goes down sharply. Okay, and then eventually there are no leaves at all. Okay, well, this graph C shows that there should have been some type of constant wording in our thing, and it doesn't say that at all. Okay, so we know this one is out, and we know that graph B would be our only solution. Okay, so on that one you're looking at for graph B. All right. Okay, you try. We want to come up with a graph that represents this situation. And it says, a truck driver enters a street, drives at a constant speed, and stops at a light and then continues. Okay, so we want to draw a graph that represents this scenario. All right, so it says a truck driver enters a street, so that means his speed is initially increasing. Okay, so he enters the street, his speed increases. Then he drives at a constant speed. Remember, a constant speed is just a horizontal line. Then he stops at a stoplight, so his speed completely stops. And he would then continue on, so his speed would slightly increase. Okay, so let's try one more. And it says the level of water in a bucket stays constant. Okay, so we know the level of water in the bucket stays constant. And then it says a steady rain raises the level. Okay, so we know the level of water in the bucket steadily raises. And then the rain slows down. Okay, but that doesn't mean the level of water in the bucket doesn't increase. It just increases a little bit slower. And then finally, it says someone dumps the bucket. Well, the level of water in the bucket would then be back down to 0. Okay, so there is a couple of different examples. Hopefully that helps you out a little bit. All right. Okay, so I want you to ignore the graph up top. Okay, go ahead and skip down here to the sentence. And what I need you to know is that some graphs are connected lines or curved lines called continuous. Okay, continuous graphs. Okay, sorry, the handwriting's really bad. And some graphs are only distinct points, and they are called discrete. Okay, connected lines are called continuous, and some graphs that are only distinct points, those are called discrete. Okay, so let's look at this example right here. We have a theme park attendance, and we're comparing people and years, and we want to know if this is a continuous graph or a discrete graph. Well, as you can see, you just have a bunch of individual points or distinct points, so this would be a discrete graph. All right, so it says sketch a graph for the situation. Tell whether the graph is continuous or discrete. Okay, so we want to go ahead and make a graph that represents the situation. So if we made a graph, and on the left side we have books sold, and we know on this it says a small bookstore sold between 5 and 8 books, so our only option is to have either 5, 6, 7, or 8. And on the bottom, we know that we have days, and we have 7 different days. So 1, 2, 3, 4, 5, 6, 7. Okay, so let's go ahead and graph it. You know that, let's say, the first day we sold 6 books. The second day, 8. And I'll just fill in a bunch of different random amounts for each day. Okay, well, if you fill out that graph, this is a bunch of different individually plotted points. It's not continuous, so this must be a discrete graph. All right, so today we practiced a little bit of how to go ahead and solve some of these problems and turn them into graphs, as well as determining if a particular graph is discrete or continuous. See ya.